Welcome to another ABS online video. Let's go and find out what we're going to learn today. It's too hot in week 28. Every year our world seems to be getting hotter. I do like the summer, but it's getting extreme. This is the number one biggest problem our world faces. Not climate change? Okay, but maybe today's topic will help us to reduce climate change a little. Now, you know, we've been talking about renewable energy, clean energy. What is it today? How can we reduce climate change? Even if it is just a little. If everyone does just a little, well, that will make one very big. That's what we want, a big change. We have another great way to produce clean electricity. That is our aim. We need electricity. We need it all day, every day, for almost every person in the world. Now, that's the problem, isn't it? That's a lot of people needing a lot of electricity. So what about last week? Let's look at last week just briefly. What was it? Last week we looked at hydroelectricity. There we are. We need lots of water. Hydro. Whenever you see that word or that prefix, it means water. Huge amounts of water were used to spin turbines. Remember turbines? They are very important. They really are super important. Turbines, things that spin round very quickly. A turbine sort of looks like a fan or a windmill. There we are. That's a very good turbine. That is just like a turbine you might see in any power plant where electricity is produced. Turbine, very important. So this week, why is it hot this week? We are going to look at geothermal energy. Okay, we're going to look at that word carefully. Geothermal energy. Well, the energy bit, that's easy. We know what that is. Geo means earth and therm means heat. Let's see if we can think about that a little bit more. Geo, geography. Geo, earth. Therm, thermometer. Therm, heat. Geothermal means heat from the earth. We know that heat comes from the sun, but geothermal is heat from the earth. Okay, that's for later. We have already said that spinning a turbine makes electricity. Yeah, great. That's what we need to do. Spin the turbine. But how? What? How do we spin the turbine? Well, we know that. We sort of make steam or hot air. That will spin the turbine. Is that what we mean? No, not quite. How do we make electricity? Okay, why? Why does a spinning turbine make electricity? Well, in the middle of the turbine is a spinning magnet. It's usually just a big round magnet. Spins very quickly. This magnet is surrounded by wire coils. Okay, so we've got the magnet and it's surrounded by wire coils. So how does that help? This makes a magnetic field. So a big area that's really magnetic. Free electrons around the atoms within the magnet and coils can flow away, and this is electricity. So, surrounding every single atom in the universe, there are electrons. Now, sometimes if we use the magnet and the coils, we can bump those electrons. We can make them move. We can bump lots and lots of them and make millions and billions of them move along. They flow away. And these flowing electrons are electricity. So, let's see. Spin the magnet, make the magnetic field, that will bump the electrons, and if you get enough of them, you will have a flow of electricity. Sounds easy, doesn't it? I think it's a bit more difficult than that. I tried to make it easy so we could understand it. It is a bit confusing, but then we have electricity. Great! Oh, spin that turbine. Last week we looked at hydroelectricity. Now let's look at geothermal energy. It's clean and will never run out. Well, maybe one day it will, but I think humans will not be on this planet at that time. So we don't need to worry about that. We will not be here. So how does it work? The centre of the Earth is super hot. Hotter than the surface of the sun. That's pretty incredible. When that heat comes close to the surface, it can make groundwater really hot. Groundwater is water that has come from rain and slowly gone through the soil into the rock, and it collects deep in the earth. It's called groundwater. So how do we see it? Water comes to the surface as geysers or hot springs. Now that word geyser, some people might pronounce it geyser, but they're hot water springs. Sometimes they bubble out of the ground. Sometimes they shoot up really high with enormous power and pressure. Hot lava from a volcano is another form of geothermal energy. Heat from the earth. How do we control that? You do not want to get anywhere near a super hot geyser or lava. So, we don't use heat at the surface of Earth because it is too unpredictable. It is best to drill down several kilometers to where the heat is constant. If we can find constant heat, then we know that the energy produced can also be quite constant. So, not near the surface, very dangerous. Let's go down and down. So then we use the steam from boiling water under pressure. That's got a lot of power. By drilling in to the super hot groundwater, we can release it as steam. This high pressure steam rushes up to the surface where it drives the turbines. So that's a simple process. Get the steam, drive the turbine. We need to drill down, release the steam, drive the turbine, make the magnetic field, and then the electrons will flow as electricity. Now let's talk about Iceland. Iceland. Do you know where it is? It's an island in the middle of the North Atlantic Ocean. It's not too big, but it's not too small. A medium-sized island with about 350,000 people there. It's called Iceland. That tells us something. It is pretty cold, but we're talking about heat geothermal. But Iceland is a great example of using volcanoes. Not lava. They have so much geothermal energy that people there pay very little for their electricity. Wow! You go and ask Mum and Dad, how would they feel if their electricity bill was just a few dollars each month? That would be great. Well, that's what the people of Iceland have. Now they use it again and again. How do they do that? They use the hot steam from deep wells, but as it cools, they pump the water back down to be reheated. Recycling! That's great. Of course, deep underground, there is a limited amount of groundwater. So if we take many millions of litres every day as steam, it will run out. That's not renewable energy. So, in Iceland, they put the water back. What a great idea. Recycling. Wow. recycling renewable clean energy. That sounds just perfect, doesn't it? Now, this is also really good. People's homes use a little electricity, but big industry uses lots and lots and lots of electricity. Iceland has a lot of energy intensive industries. They need lots of electricity. So, that means that Iceland sort of could be a very dirty and polluted place, but it's not. Geothermal energy helps industries such as aluminium smelters to be much cleaner. So, getting raw products out of the earth is very dirty. So, we could never make that kind of industry clean, but using geothermal energy really helps. Not perfect, but so much better. Now, we've got a good word there. Aluminium. Aluminium. It's a silver-coloured metal. I'm sure you've seen it. I'm talking about it here because in America they say that word a little bit differently. They say aluminum. England, aluminium. America, aluminum. They're nearly the same, but definitely different. But the same metal. So don't worry. Again, whichever way you want to say it, that's great. Now, many people are trying to learn. Many countries around the world are trying to learn from Iceland. Iceland are doing a great job with their geothermal energy. They're trying to teach the world. Indonesia. Indonesia has lots of volcanoes. Geothermal energy could supply 30% of all its energy needs. Now that is amazing. Go and have a look at the population of Indonesia. There are many millions of people living in Indonesia. It's one of the most populated countries in the world. So if we say that geothermal energy could supply 30% of its energy needs, that's amazing. That shows how much potential geothermal energy has. Are there any problems? It's all very well me getting really enthusiastic, but there are always going to be problems, aren't there? Drilling very deeply in areas close to volcanoes could trigger an earthquake. That would be very rare, but it is possible. And we know earthquakes are devastating. So we really don't want that to happen. And it takes a very long time to develop the structures needed. But people want electricity now and don't want to wait. New structures for new big projects like this are called infrastructure. Infrastructure is essential for any society. And we need the infrastructure to be really, really good before we can start to get any electricity. And that takes a very long time. So it sounds mostly good, doesn't it? Yes, it's something we need to be determined about. Geothermal energy comes from deep within the earth, which means it is everywhere all the time. Everyone lives on Earth, and deep within the earth is underneath everyone's feet. Are we determined enough to make the change? Well, I think as individual people and families, we can't really make that decision. What we can do is try to encourage our government to make the decision. Tell the government to spend some money to try and develop clean energy. It will take a long time, but I think most of you out there are quite young people. Think about what the world will be like when you are very, very old. That's why we've got to start thinking now. So, one more way to make electricity. Next week, we will look at one more way to make clean electricity. Great! You may have seen this one. I think you have. Maybe we haven't seen geothermal electricity. Maybe you haven't seen big dams to make hydroelectricity. But next week, I think you would have seen it. What will it be? Well, there's only one way for you to find out. We will see you next time. See you soon. Bye. Thank you for watching our video today. Please don't forget, subscribe, and that will help us to make lots more videos for you. Thank you. Bye.